This is a quick overview of the cabling for an Eberspacher D4 heater. This is a short lead. You can actually buy this lead in this configuration, but normally they're a lot longer. Now it's just going to work. The main connector just pulls apart, he says, come apart like that. And what we've got here are the two cables going to the fuel pump, 12 volt supply and ground, and these are heavy duty cables. These are supplies and for the glow plug and the fan, and these will go probably to a 30 amp fuse somewhere in the van. There's a connector here that goes to a brown and white and grey wire. The brown and white wire is a reference earth. It's an isolated earth, so you don't get noise on it, and the grey wire is a bypass. The bypass is the internal temperature sensor alongside the cooling fan inside the heater itself, and you can get much better temperature control and modulation, i.e. fan speed control, when this is connected to an external sensor, and that external sensor is dangling, I can't see it, dangling just there. He says wobbling it. Dangling just there. It was originally on the left hand wall, high level. I've disconnected it, and I had to cut the cables in order to get it out of the bulkhead, so I've got that on a bit of a terminal block at the moment just to reconnect it. But having one of those allows the heater to modulate properly, assuming you've got a decent controller as well. So back to the cabling. The only other connector is this black one, and this is the connector that goes to the temperature controller, the rotary temperature controller on the wall, and this connector can be used for all sorts of different controllers. In this case you can see there's a lot more wires going into it. There's a red wire there which would normally provide 12 volts of controller. It's not connected on the other side in this instance. All you've got here is yellow. Yellow is heater on. The other wire, brown and white again, reference earth. Brown wire, ordinary earth, and that one there is the output from the temperature controller, and it has a voltage on it. So that's it in a nutshell. This is what all the cables do, and in order to get this running I need to power this up and put 12 volts on there. So I shall do that shortly and just show the heater running. The controller in this installation is this rotary controller. You can't easily tell what sort of temperature range this is going to set to. There's a lot of hysteresis or latency in the way the heater responds, so you'll stick this to 2, wonder what's going to happen for 10 minutes, wind it back a bit, and it's not like your normal thermostat in the house where you can actually hear a click for a given temperature. It's not a brilliant thing to use, and I'd much prefer to fit an 801 controller which has a temperature display on it. On the back it's got a standard set of spade terminals, and the connector here basically matches the wires that are coming out. Oh, it says put it in the right place. The connector here basically matches the wires coming out of the black connector on the heater itself, with the addition of one extra wire. With the addition of one extra wire in the harness. There's also a grey wire here, so it would be possible to actually wire in a better type of controller directly to this cable here. It's using the standard Eberspacher wire colour scheme, and the fact they've included this extra grey wire in the harness, although I haven't, did I see it at that end? It's probably at the other end as well somewhere, would mean that you could actually replace having the other temperature sensor that I showed just now, because the 801 has 2 built-in temperature sensors, one that controls the grey and red wire directly in front of me, and the other one that controls this grey wire. And these heaters work very, very well when they're not reliant on the temperature sensor attached to the side of the ECU fan body in there, because you can imagine that if this heater is located somewhere else, under the floor or maybe under a seat, separate from the area it's heating, then measuring the incoming temperature of the air in its location may not reflect anything like close to what the temperature is in the place you're heating. So it works using the internal temp sensor, but it's much better to have an external one like this little thing dangling here, or at the moment my favourite is the 801 controller. Well, that threw me for a few seconds. The yellow wire should not be a powered cable, and that's normally the output from the controller to turn the heater on, and you stick 12 volts on it. And I was sitting here looking at these colour codes thinking, what are they playing at here? And there's an extra wire at this end that isn't at the heater end, and that's this blue and white one, which I've actually got this test lead plugged into. Now, Eberspacher heaters, normally the blue and white one is a diagnostic lead. And I thought that's handy, they've got a diagnostic line here. But no. The ambulance converter has used a blue and white cable down the harness. It comes out in connector A and goes to the Genesis heater output. There's a good curveball. Maybe just a coincidence, but why use the wrong colour cable, or a cable colour that's recognised for another function? I don't know. But end result is blue and white wire, 12 volts on it. That will engage the heater via this controller, and 12 volts on the big thick cable for the heater itself. Right, I'm not sure how well the sound's going to be, but this one sounds beautiful. Mine don't sound like this at all. Mine make the most horrible racket, but this is flat out, and that motor's lovely. And when this throttles back, that's going to be near silent. Mine's got a brand new motor in it, one of mine, and it makes the most appalling racket. I'm going to have a good look at it. Anyway, very quick wiring exercise. I've got the high current 12 volt feed directly into the 12 volt supply. They're throttling back now. Into the 12 volt supply that goes to the blower and the glow plug. I've got a smaller 5 amp fuse, or is it 7.5? 5 amp fuse wired through a bit too long a wire into one of the pins for the Genesis harness, which then effectively goes up to the controller on my left. And I think I mentioned previously, they've used a blue and white wire for the 12 volt feed, which is a no-no in my books. It's the wrong colour for an Eberspacher system. Threw me a bit. Now, on the DVM, that is the output voltage from the little thermostat that is now dangling above my head. When that voltage is slightly above the voltage coming from the thermostat controller, the heater will do what it's doing now, and it's throttling back. And I suspect the difference is about 10 millivolts. So if I now just swap over the DVM from the temperature sensor to the output from the controller, they're exactly the same. 2.57 volts. That's actually pretty good. On my 801 there's a difference of about 10 millivolts. So it's now equalised. The temperature sensor, the remote temperature sensor, knows the temperature in the van matches the demand from the controller. I don't actually know what temperature in there is. It's quite cosy at the moment, considering how many holes are in this machine at the moment. But that is now beginning to modulate, and as this voltage continues to rise, sorry, not this one, the other one, 0, back to that one there. As this voltage here begins to rise above the preset voltage from the position of the controller, this heater will begin to modulate further and further back. So at the moment it's still chucking out nice and toasty, my leg's getting warm, still chucking out heat. I suspect the vehicle is still warming up more than required. So we'll see this rise to 2.59, 2.6 volts. The reaction of the heater will be to reduce the pump rate and the fan rate, and that is what the term modulation is, so that eventually there is an equal voltage between this and the demand from the controller, and at that point it will just run along quite happily at its lowest speed, which on this unit is going to be not near silent. It's going to be a whisper. It's going to be a heck of a lot quieter than my one. That is amazing. They're both, effectively I've got 3 of these to play with here. This one and the 2 in my vans, and this one is much quieter. I wonder if I bought a crappy motor. I'm beginning to wonder now if this motor I bought was actually truly brand new or not. There's a lot of clones available on eBay. It was supposed to be a genuine Eberspacher motor that I bought from a genuine Eberspacher dealer, but I'm beginning to wonder now whether I bought some rubbish with noisy bearings. But there you go, 2 wires. One straight into the connector here because that was the most convenient place. I could have pushed it into the other connector, which goes into the Genesis relay panel, but it was easier for the purposes of connecting the controller wire to go straight into the pin on that round connector there, once I'd buzzed it out and identified it. And the way I did this is I went and looked at the Genesis control panels in my garage, found the label that said heater output, followed the cable down, identified which pin it was on this connector number A. They're all numbered. Sure enough, I could then find it on here, buzzed it out to make sure it did go where I thought it did, buzzed it out to make sure it didn't go anywhere else, because obviously I've got wiring all over the place here. And there you have a heater that's working. And that means I can run this independently. I'm actually running it off a gel battery that came out of my Sprinter. This battery it's warped. You can see it looks like it's been overcharged. It's not at all happy. I wouldn't use this in my vans for anything, but it's very useful for playing with. I've got a few spare batteries I use. But hopefully you've been able to hear me, otherwise I'll have to do a complete voiceover of this. So there you go. Quick recap then. Probably the easiest thing to do of the cabling here. 2 wires go to the pump. Those 2 there, they can actually be anywhere around, I believe. Main plus and minus 12 volts, or 12 volts and ground. Provides power only to the fan and the glow plug. Separate connector there going to the remote thermostat over there. Multi-plug there which goes to the controller, and that multi-plug can be used for all sorts of different controllers. You can buy, I think you can buy a 701 with an 8-pin connector on it that plugs straight into that. I think the 801 doesn't, you'd have to wire that differently. And then everything gets presented to that standard connector which all D4s have there. There you go, she's beginning to modulate back a bit. You'll see that that voltage there now is 2.6 or 2.59. So this thing's literally working on... He's working at 10 millivolt steps. Sorry, I think I've decimal place in the wrong place. Yeah, it's working at 10 millivolt steps, exactly the same as my other one does. So 10 millivolts creates a difference in demand. And now this is going right down. You can hear the pump in the background perhaps. Duty rate about once every 2 seconds, twice every second even, get that right. Fan's ramping down. And it will now stay at this fan speed until this voltage begins to fall. If this voltage continues to climb too much, it may actually turn completely off, but typically it will now modulate at this lowest speed all day. I haven't got a current clamp fitted at the moment, so I can't tell you what it's drawing, but this motor is probably now drawing about 1 amp and a bit, whereas when it started up it was nearer 10 to 12 amps with the fan flat out and the glow plug on. And that's what they call these night heaters. Once they're modulating right down to the lowest setting, especially if this is in a sealed box under the vehicle, with a muffler on the exhaust and on the intake, these are quite silent. Well, I think you could sleep with that within reason. I've just been outside. It's actually noisier outside than it is in. And this doesn't have a silencer on it. Very tempted to put some silencers on mine as well. But you can buy an air intake silencer and an exhaust silencer. The air intake silencer, I'm not really sure what that actually achieves. But the exhaust silencers, they certainly work. I've just gone and got my temperature sensor, temperature meter, and I've stuck the probe right next to the sensor up there. I've got dangling up there on a bit of cable. I'm just curious to see what the temperature actually is in here. It feels nice and cosy at the moment, but that says 14.3 degrees. I might wind it up and see if I can get it at a steady 18 and see what that equates to on the thermostat, which is, if I think I did film it earlier, it's up there. I've got the thermostat here set to number 1, and I'm just going to leave the temperature stabilise in this room for a little while, because obviously this sensor here is the one that's actually telling the heater what the temperature is. This sensor effectively bypasses the internal air temperature sensor, which can be a bit unreliable. There's my cable for my temperature probe, and the temperature probe is that metal bit. Is it going to focus? Focus? Yeah, it's just behind there. And at the moment it says, where am I pointing the camera? Oh, 15 degrees. I think you'll get the hang of this fact. I'm not pretty good at filming anything. I like cameras with viewfinders, and this silly thing, half the time I can't see where I'm pointing it. And I've got it zoomed out, haven't I? So, 15.7 degrees in here at the moment. It's quite cold outside today. I'm glad I've got this working, because I may well need to have it on tomorrow. And that's just ticking away beautifully. So, in theory then, if I move that round to the meter and I transfer what I'm measuring to the input voltage, this is the voltage that go in the hole. That's the voltage coming from the thermostat on the wall, and that's the thing that's effectively telling the heater what temperature is required. Now this is interesting. In my van, that voltage at this temperature, 16 degrees, would be 2.36 volts. So it's pretty obvious that the controller on the wall here and the sensor that I was pointing the camera to a few minutes ago, that's actually telling the heater what the temperature is, they need to match. They need to have the same output. They need to be a matched pair. I hadn't thought that before. I thought they'd be using consistent values, but clearly there's a difference, because this is totally different voltage to mine. For mine, the 801 controller, 2.36 volts, 16 degrees on both cables. Right, I'm going to wind this up to number 2. So it currently says 2.6 volts. In fact, I'll stick it on number 3. There you go. So it's a rise of 14 millivolts. The pump's already ramping up, you can hear it, and the heater's ramping up. Set it back to number 2, 2.67 volts, and now the heater will go back to flat out, or as near as damn it flat out, until I'll just move the pin over. Back to the grey one, which is the control. Oh, I've lost my voltage. Where's my ground gone? That's fallen out. Go back in the hole. And now you come out. Go in the hole. There you go. So, that's the signal from the temperature sensor dangling above the ceiling. That now needs to rise to 2.67 volts to match the demand from the thermostat before the heater throttles back again. And that's how it works. And that's how modulation works. And it's brilliant. Absolutely brilliant. I've just wound the thermostat back down again, so I don't want it going cookingly hot in here. I'm interested in know what a steady 20 is. I mean, it'd be interesting if the 1, 2, 3 and 4 actually mean 10, 20 and 30 degrees. I'd be surprised if it does, but it may be close. It may be an approximation. There she goes, coming up to full speed again. That is a lovely sounding little motor. That's not going to be the original motor in this van, considering the mileage this was done. Great little bit of kit. Well, that shot my theory in the foot. I've had to wind this controller right back. It's on about, well, I don't know, if that was a scale of 10 to 20, with 1 being 10 and 2 being 20, that's on about 12 now. And that equates to a temperature in the room of 23 degrees. So I've just backed it off until the voltages match, and the heater is now throttling back again. It's going to bottom out around about 23 degrees ago, I think, with that controller set to 12. So setting it to number 2 or 20, probably on a freezing cold day, will create a completely different temperature in here to no, it won't. No, it's going to be consistent. No, it's just setting the voltage based on a number you set the dial to, so it's purely down to when this sensor here matches, so it's going to be consistent. The dial just means nothing. I didn't think much of these little controllers initially. I didn't think it was actually a modulated controller, but it does. But as I've just demonstrated, you've got no way to tell what the temperature is based on where the dial is. It's a learning curve. But, you know, it's working. It's working better than I thought it did. I've just pulled the fuse out. The small fuse basically says to the controller, switch off. The unit is still connected to the main 12 volts, and what's happening now is the pump has stopped, ignition stopped, the flame's gone out, and the fan is now going through the purge and cooling process for a few minutes. It actually does this with the glow plug on as well, because it's burning off any residual diesel that may be in the chamber. I think as a default 2 minutes or 3 minutes this runs for. And this is where these can be power hungry. If they're not being modulated properly, if they're just going on, off, on, off, on, off, because they're using a very crude controller without proper temperature sensing, then every 20 minutes of glow plug on, glow plug off, glow plug on, soon flattens your battery. But modulating properly, running at this sort of speed, they are very, very, very economical, both on battery usage and fuel. They burn about 0.1, 0.2 litres an hour depending on how flat out they're going. So you're looking at 15-20 pence an hour to run them, which ain't bad considering the usage. And if you switch to an alternate fuel such as red diesel, or even better still domestic heating oil, they're much, much cheaper, because it does seem a bit daft running these on vehicle fuel when you pay so much tax on it. But the vast majority are plumbed in using the vehicle's fuel tank, but they can be much more efficiently run, or economically run even, using a separate fuel source. The downside is the plastic tanks are silly money. It's almost worth buying a Chinese diesel heater just to get the plastic tank for the diesel, because I think the stock Webasto or Eberspacher tanks, they're 50, 60, 70 quid or whatever they are, for basically a plastic bottle. But there you go. I better stop waffling now, otherwise it's going to be another one of these long videos and everyone will be yawning and falling asleep.